All right, so it says for exercises 1 through 3, you're writing independent or dependent. All right, so first one says you roll a 2 on a number cube and spin a. So independent dependent is, does the outcome of the first event impact what's going to happen in the second? So does me rolling a 2 on the number cube affect what I spin on my spinner? No. No. So these are independent events. If they have no effect on each other, we call them independent. The first one would be. You choose a king from a deck of cards and get a heads in a coin toss. Does the fact that I pick a king from the deck affect if I'm going to flip a heads or a tails on a coin? No, these are completely unrelated. So this is an independent pair of events. You roll a number cube and get a 6 and roll again if the first roll is a 6. Does what I get on my first roll impact what I do on my second? Yeah, because I'm only rolling the second time if what happens. I need to get the 6, right? If I don't get the 6, I'm not going to roll again. So what I get on my first roll impacts what I'm going to do after that. These are dependent. In Friday's class, we learned that if we could call 2 events independent, then we can calculate the probability of both of the events happening by multiplying them. So like finding the probability of event 1, finding the probability of event 2, and then if both of them are going to happen and they're independent, then we can multiply them. So the next question says, if these are independent events and these are your probabilities, then what's the chances of both of them happening? So we learned that P of A and B happening, both, is the probability of A multiplied by the probability of B. In math, and means multiply. So I take the probability of event A, which was 1/2, and I would multiply it by the probability of event B, which is 2/7. You can do that in your calculator a few ways. You can use parentheses around your fractions. That. But some of your calculators have this feature where if you hit the green button, alpha, and then y equals, you can make a fraction itself, and then you don't have to math bracket. It will do that already. So either way, we're getting 1/7 here. Or if you're doing it by hand, you're just multiplying straight across. 1 times 2 is 2, 2 times 7 is 14, and then you would have to reduce that fraction. So doing it in the calculator skips that step and reduces it for you. The last one says, what's the probability of rolling a 4 on a fair number cube and getting a tails when tossing the coin? So the first thing I need to do is find the probability of getting a 4. A fair number cube has 6 numbers. How many of those numbers are 4s? 1 out of 6. So the probability of getting a 4 is 1/6. A coin has 2 things, a heads and a tails. How many of them are tails? 1. So the probability of tails is 1 out of 2. So the probability of both of those things happening is the probability of getting a 4 multiplied by the probability of getting a tails. You can type that in your calculator or multiply straight across, but that probability is 1/12. So independent means the outcome of the first event, what I get on my dice, is not going to impact what I get on my coin. They're independent. If they're independent, then to calculate their probabilities of together happening, both of them, is to multiply them together. This is what we did on Friday's class. Right? Today, we're going to determine if, the warm-up was, I can determine if 2 events are independent. I can calculate the probability of events that are independent. We're going to work on finding if 2 events are mutually exclusive and calculating their probabilities, and if 2 events are overlapping and calculating their probabilities. So these are all different types of events. Independent are 2 events that don't affect each other. Mutually exclusive, they do. Okay, so like what happens when they do. So we're gonna use our toolkit today for most of our examples, and then we'll eventually get to a closer up online. So I don't have any examples in your workbook. If you wanna put your workbook away, you won't need that anymore. This is me. I took a class at Westchester, a technology class, and I had to make a video for it. So I actually made it for this unit. So I made a video showing what mutually exclusive and overlapping are, because I find that most kids struggle to know the difference between the two things I'm gonna teach you today. And I wanted to make something like realistic. So I don't know if I ever used it in this class, but if you had me last semester, I did. You know the wheel of names where I spin and randomly call on you? So I used that as the example. It's a little corny, but I feel like it does get the job done, so. This is an introduction for mutually exclusive.
A math teacher with an impossible task, to get warm-up answers from her freshman students. Meet Mrs. Diamond's math students, rowdy and chatty when class is over, but painfully silent when it's time to participate in math class. Meet the Wheel of Names, a torture device created to randomly call on students to involuntarily provide answers to said warm-up assignment. Today, Mrs. Diamond will spin the wheel to get the answer for warm-up question number 1. The students wait anxiously, hoping and praying the wheel will not land on their name. Kim and Jason are especially scared. Kim because she chose to fill up her water bottle instead of completing the warm-up assignment. Jason because even though he did do the warm-up, he is absolutely lost. What is the probability that the wheel will land on Kim or Jason? Time out. Let's talk probability. The probability of the wheel landing on Kim or Jason is called mutually exclusive events. Mutually exclusive events are two events that cannot happen simultaneously. In other words, if one event occurs, the other event is impossible. If the wheel lands on Jason for warm-up number 1, can it land on Kim for number 1 too? No. The wheel cannot land on two names at the same time, which is why this is a pair of mutually exclusive events. To calculate the probability of mutually exclusive events, we take the probability of event A and we add it to the probability of event B. Now, let's get back to that wheel. What is the probability that the wheel will land on Kim or Jason? Well, first we need to know the total number of possible outcomes, so we will count the number of names. 1, 2, 3, 4, 5, 6, 7. So there are a total of 7 names on the wheel. Of those 7 names, how many of them are Kim? 1. So the probability of the wheel landing on Kim is 1/7. Of those 7 names, how many are Jason? Also 1. So the probability of the wheel landing on Jason is 1/7. Remember what we said about mutually exclusive events. The probability of A or B is equal to the probability of A plus B. So the probability of getting the wheel to land on Kim or Jason, we simply need to add their two probabilities together. 1/7 plus 1/7 equals 2/7. The probability of the wheel landing on Kim or Jason is 2/7, a pretty low chance. So Jason and Kim are relieved.
All right, so the key here is that in mutually exclusive events, you're going to see the word or, okay? And would be like, what's the chances that the wheel lands on Kim and then Jason, right? And is like, two things are happening here. I'm going to spin the wheel twice. It's going to land on Kim the first time and Jason the second time. And I'm going to multiply them because multiple things are happening, okay? This one says Kim or Jason. I'm only spinning the wheel once and only one of those things is happening. Okay, so the key here is you gotta understand the difference between multiple events and a single event. Or it's gonna be one event, okay? If those two possibilities in that one event are impossible to happen at the same time, then it's mutually exclusive. If those two things can happen at the same time, then it's this new thing called overlapping that I'll show you in a little bit. Alright, so mutually exclusive events are two events that can't happen together. You're only going to use mutually exclusive probability if you see the word or separating your two events. If and comes in, that means both events are happening, and you're going to multiply them, all right? So we're going to read some situations, and we're going to see if we think they're mutually exclusive or not, all right? So the first one says, and this is in your toolkit, the first one says, you are making a prediction about your next test score in math. What is the probability that it will be an A or B? I want to figure out if those are mutually exclusive, all right? So the first event is getting an A on the test. That's the thing on the left-hand side of the or. The second event would be getting a B on the test because it's A or B. Event 1, I get an A on my next test. Event 2, I get a B on my next test. Mutually exclusive is, can both of those events happen at the same time? You're taking your next test. Can you get an A and a B on the test? You can't, right? So if those two things can't happen at the same time, they're called mutually exclusive. So this is a no, they can't happen at the same time. And if the answer is no, they can't happen at the same time, then what you're going to write for this is that these are mutually exclusive events. So when we're determining if something is independent or dependent, it was like, does the outcome of the first event affect the outcome of the second? If you're determining if something is mutually exclusive, it's, can these two events happen together? I'm taking one test. Can I get an A and a B on that test? No, that's mutually exclusive. If the answer is yes, then that's called overlapping, which I'll show you later on in class. All right? So the next one says, you are rolling a fair number cube. What is the probability that you get an even number or a multiple of 3? So I listed out the number cube for us. So let's think about if my first event would be getting an even number. So if this is my number cube, my even numbers are 2, 4, and 6. So event 1's outcomes are 2, 4, and 6. Event 2 would be multiples of 3. Anybody remember from last week what my multiples of 3 are? Remember, multiples multiply, they get bigger. So we're going to start at 3 and get bigger. What's another multiple of 3? 6. So when I'm asking myself if they're mutually exclusive, I'm looking at each event and I'm seeing if they have anything in common. Is there something that's even that's also a multiple of 3? Do you see a number that's circled in both lists? 6. So can these two events happen at the same time? Yes. I can get an even number and a multiple of 3 on a single roll because I could roll a 6 and now I'm getting both. Does that make sense? So these are not mutually exclusive. Mutually exclusive are two events that can't happen in one roll. So the answer is yes. So these are not mutually exclusive. Because in one roll I can satisfy both outcomes. The last one is about a deck of cards, and I have learned over the years that students do not know nearly as much about a deck of cards as I thought they did. So I have a picture here. It's kind of small, but I think it'll get the job done. So it says, you randomly select a card from a deck of cards. What is the probability that you choose a heart or a diamond? So event 1 is picking a heart, right? There are 13 heart cards in the deck. Event 2 is selecting a diamond card. There are 13 diamond cards in the deck. Are there any outcomes from my red circled problems that also show up in my blue circled problems? In other words, can I pick a card, one single card, that's going to have a heart and diamond on it at the same time? Does that card exist in the deck? None of these cards have both a heart and diamond. They either have one or the other. There's no repeats in these two things. So, is there common outcomes in both events? No. There's nothing in the red event that's also in the blue event. So these are mutually exclusive. when we're determining if something is mutually exclusive, we want to look at the two events and figure out if in one choice I can get both events satisfied. If one pick of the card can have both a heart and diamond, no. If one roll of the dice can have an even or multiple of 6, yes, because multiple of 3. Yes, a 6 satisfied both events. That one's not. All right. Once you can determine that something is mutually exclusive, like 27 and 29, then there's a formula to calculate its probability. The formula is the probability of A or B is equal to the probability of A plus B. Probability of A and B is P of A times B. So you're going to start to have these formulas that look similar. And means multiply, or means add. Okay? So we're going to do this first one together. It says student athletes at PWHS can only participate in one sport each season. During the spring season, 28% of students play baseball and 24% of students run track. What is the probability that a randomly selected student athlete plays baseball or runs track? There is not a single student in this school that I'm gonna pick out of a hat that's doing both, okay? I'm pretty sure it's like a PIAA rule. You cannot play 2 sports in one season, right? So I'm not gonna randomly pick on someone who's on the baseball team and the track team at the same time. You can't do both of those things. Because you can't do both, it's mutually exclusive. Mutually exclusive is when you can't do these two things at the same time. So if you have a mutually exclusive pair of events, then to calculate their probability, you'll take the probability that the first event happens and add it to the probability of the second. So the probability of a student playing baseball in the spring is 28%. We can keep it as 28%. The probability of a student running track in the spring is 24%. So the probability of randomly picking a kid in the school, that's one or the other. I'm just going to add those two things together. So I'm going to do 28% plus 24%. Kind of squeezing that in there. 28% plus 24%. 52%. Mutually exclusive, add. Alright? Second one says, a jar contains 10 red, 8 green, 5 blue, and 6 white marbles. If you are choosing one marble at random, what is the probability that it's green or blue? Okay, so we've got these marbles in the bag. I'm going to close my eyes and I'm going to pull one marble out, just one. Can it be green and blue at the same time? No, there's no marble that's mixed colors, right? So because I can't have both of those things happen on one pick, it's mutually exclusive. Right? They can't happen at the same time. Mutually exclusive. If they're mutually exclusive, then we can add their probabilities together. So the first thing we have to do is figure out, well, what's the probability of getting a green marble? There are 8 green marbles. Out of how many? 29. 10 plus 8 plus 5 plus 6. 29. Then we need to find the probability of a blue marble. Well, there are 5 blue marbles out of 29. So the probability of one or the other is adding them together. If I was doing 2 picks and I wanted to find the probability that my first pick was green and then my second pick was blue, I would multiply them. Multiple events happening is multiplication. Only one's happening here. I'm only choosing one marble. So I'm going to add them. 8 29ths plus 5 29ths. When you add fractions, you keep the denominator the same. Okay? If you don't feel confident in knowing when to add, when to multiply, the calculator will do it for you. Okay? You don't have to know how to add fractions in this class. You should know how, but that's not what I'm testing you on. So you could do this. Was it 5? Was it 8? 5? Okay. So you could do this, math, enter, enter. You can use the alpha y equals tool and make them fractions that way. You don't have to add them without a calculator. You can use the calculator.
Can you just keep it as a fraction? You need to put it in a percentage.
You don't. You can keep it as a fraction. So 1329 says my answer. I like to keep it in whatever form the problem gives it to me. So since the first problem was percentages, that's why I kept it that way. This one didn't have percentages, so I don't need it. We okay with that one? All right, you guys try the last one. I put the events on the board so you could see them, which might help with you finding each probability separately. So try it. It says you pick a card from a 15 sequentially numbered deck of cards. So I have like all 15 cards here if you need to see it. If you choose a card at random, what's the probability that it's an even number? So event 1 is an even number, and event 2 is a 7. Those are mutually exclusive because I'm not going to randomly pick a card that's a 7 and also even. Because if it's a 7, it's not even, right? They can't happen at the same time. So see if you can find their probabilities of an even or 7. All right, how many numbers up here are even? How many? Let's see. 1, 2, 3, 4, 5, 6, 7. 7 out of 15 numbers. How many numbers up here are the number 7? 1 out of 15 numbers. So if I want to decide the probability of choosing an even or 7, I'm going to add them together. 7/15 plus 1/15. You can type that in your calculator, or if you're doing it by hand, you're adding the numerators and keeping the denominator the same. That probability is 8/15. 8 out of the 15 numbers are either even or the number 7. You okay with that? So we've got independent events. Multiple things are happening. Right? Independent events, 2 or more events are gonna happen. I'm gonna pick the even number, and then in the next breath, I'm also gonna pick the 7 again after that, right? So 2 things are happening. If that is the case, then I'm multiplying. Mutually exclusive event, only one of them is gonna happen. Not only is one of them going to happen, but the 2 different events don't have anything in common, right? There's nothing that could happen in the first event that could also be something in the second event. Now I'm going to add them. There's one more type, so I just wanted to reiterate these before I show you the last type. The last type's the trickiest. It's called overlapping, and I've got a video for that one too. Again,
Mrs. Diamond is back,
same idea.
and she has another warm-up question for her students to answer. Mrs. Diamond's students are back too, and some of them have not learned their lesson and decided to skip doing the warm-up today. Mrs. Diamond's wheel of name is back as well, and it is here to randomly call on students as needed. When Mrs. Diamond asks for volunteers for the first question, so back to the wheel of torture, names we go. This time, what are the chances the wheel lands on someone who has the letter A or E in their name? Well, if these were mutually exclusive events, to get the probability of A or E, we would simply add the 2 probabilities together. So let's try that. First, we will count the number of names. There are 7 total names on the wheel. How many of those names have an A in them? Jason, Juan, Frankie, and Cassie. 4 names. So the probability of the wheel landing on someone with an A in their name is 4 sevenths. Now for the second event. How many students have the letter E in their name? Cassie, Frankie, and Ben. 3 names. So the probability of the wheel landing on someone with an E in their name is 3 out of 7. So if we were to add the probabilities of A to E, we would get 4 sevenths plus 3 sevenths equals 7 sevenths, which is 1 or 100%. But wait a minute, that doesn't make any sense, because that would mean that when Miss Diamond spins the wheel, she is 100% going to pick someone with an A or E in their name. But what about Kim and Chris? They don't have an A or E in their name, yet 100% makes us feel that no matter who the wheel lands on, they will have an A or E in their name. Time out. Let's talk probability. The probability of the wheel landing on someone with an A or E in their name is actually an example of overlapping events, not mutually exclusive event. An overlapping event is a concept in probability where 2 or more outcomes share at least one common characteristic or outcome. Unlike mutually exclusive events, these events can happen simultaneously. This particular example with the wheel is overlapping because the wheel can land on someone with an A and E in their name at the same time. In other words, there are people in the wheel who have both A and E in their name. The probability of overlapping events is calculated by using the formula probability of event A plus the probability of event B minus the probability of event A and B at the same time. So let's look about what we know. The probability of the wheel landing on someone with an A in their name was 4 out of 7. The probability of the wheel landing on someone with an E in their name was 3 out of 7. But there is an overlap. How many people are on both lists? Well, Cassie and Frankie are on both lists. So the probability of an overlap is 2 out of 7. Since there's an overlap, we're going to use a different formula to calculate the probability. The probability of A or E is going to be an overlapping probability. So the probability of A in their name plus the probability of E in their name minus the people who have both A and E in their name. The probability of A, 4 sevenths, plus the probability of E, 3 out of 7, minus the people who have A and E in their name, which we figured to be 2 out of 7ths, for a total probability of 5 out of 7. So the probability of the wheel landing on someone with an A or E in their name is 5 out of 7. Let's think about why that makes sense. We'll circle the names of people who have A in their name. Jason, Juan, Frankie, and Cassie. Now we'll circle the people who have E in their name. Ben, Frankie, who's already circled, and Cassie, who's already circled. How many names are circled? 5 out of 7. This one makes a lot more sense. Thanks so much for watching, and don't forget to raise your hand in class.
All right. So, overlapping events. I'm going to be looking at these 2 separate events, but only one's happening. There's going to be an or there, okay? If there's an and, it's like multiple things are happening. This is just one. I'm only spinning the wheel once. I'm only picking one card. I'm only rolling the dice once, okay? If you're looking at one event, it's either going to be mutually exclusive or overlap. The difference is, in one pick, can you satisfy both events? If the answer is yes, if something that happens in the first event could also happen in the second, that's overlap. So in math, or always means add. But sometimes it means add and subtract. And sometimes it means just add. Okay, so there's a new formula here. So for overlapping, you have to look at the 2 events and see if they have anything in common. So this is in your toolkit. It says overlapping events share at least one common outcome. So number 33 says you pick a card from the 15 sequentially numbered cards. If you choose one card at random, so it's not independent, independent would be choosing 2 cards, Okay, I'm only picking one. So if you're choosing one card at random, what's the probability that it's odd or a factor of 6? So let's think about those two things. If I have 15 cards, the odd numbers are 1, 3, 5, 7, 9, 11, 13, 15. Right? So those are my odd numbers. What are my factors of 6? Factors get smaller. Give me some factors of 6. Nate? 1. I heard 3. 2. 6. Those are my factors of 6. If these were mutually exclusive, then nothing circled in event 1, nothing circled in red is going to also be circled in blue. They'll have nothing in common. If they're overlapping events, maybe I circled something in red that I also circled in blue. Did I circle anything in red that I also circled in blue? Yeah, I did. I circled 1 and 3 in both of these. That's a repeat. It's an overlap. So these are overlapping probabilities because is there any common outcomes? Yes. If yes, then they're overlap. If no, then they're mutually exclusive. So that's the difference between the two. It really helps to write out the events and physically see them to see the overlap, okay? So is there a number that's odd and a factor of 6 at the same time? Yes. 1 is odd and a factor of 6. 3 is odd and a factor of 6. Overlap. All right, let's look at the second one. It says, you roll a fair number cube. What is the probability that it lands on an even number or a number less than 4? So if you list out the event, right? Event 1 would be even numbers. 2, 4, and 6. Event 2 would be numbers less than 4. 1, 2, and 3. Overlapping would be that something that I circled in red, I'm also circling in blue. Mutually exclusive would be nothing's in common, okay? So what I see here is that I circled a 2 in both of these. So these two events do have a common outcome. The number 2 is common. And because there's a common outcome, that's overlap. All right, let's look at the last one. It says, you spin a spinner that is evenly divided into 8 equal regions. What is the probability that the first spin lands on a multiple of 4 or an odd number? It's the first spin. It's one spin. So it's got to be mutually exclusive or overlap. If it was, what's the probability that my first spin is a 4 and my second spin is odd, then that's independent. More than one thing's happening. But here it's just one spin. So I'm taking that one spin and I'm looking at the events. The first one is a multiple of 4. Multiples of 4 start at 4 and they get bigger. My multiples of 4 are 4 and 8. My second event is odd numbers. 1, 3, 5, 7. Is there anything that I circled in red that I also circled in blue? No. These are mutually exclusive. All right, mutually exclusive and overlapping have 2 different formulas. So it becomes tricky because they look similar. Like reading this, I see an or in all 3. So without like looking at the events, you might get confused on which one they are. But if you list them out, it becomes a lot easier to see. They had nothing in common. This is mutually exclusive. To find this probability, I'm just going to take the 2 8s and add it to the 4 8s. And that's it. But overlapping, the formula is different. Okay? An overlapping formula, this is not right in your toolkit, by the way. An overlapping formula adds them. I think that's is that a minus in yours? You should get plus. So an overlapping formula adds them just like mutually exclusive does, but it also has to do subtraction too. So or always means add, but sometimes you have to do subtraction too. All right. So it says you pick a card from a set of 15 sequentially numbered cards. If you choose one card at random, what is the probability that it's odd or a factor of 6? So we already went through our odds. So of all of the numbers, there are 1, 2, 3, 4, 5, 6, 7, 8 out of 15 cards are odd. Factors of 6. We said that that was 1, 2, 3, and 6. So 4 out of 15 cards are factors of 6. What we have to subtract is the overlap. How many numbers happen in both lists? 2. So the 1 and the 3. There are 2 numbers that repeat out of 15. Your denominator is going to stay the same. So to calculate this probability, I'm going to do 8 out of 15. That's my odd. Plus 4 out of 15. That's my factors of 6. Minus the odd factors of 6. 2 out of 15. The reason that we have to subtract them is because I'm counting them twice. And they're not 2 numbers. Right? I'm counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 numbers. I'm saying, okay, well, there's 12 numbers out of 15, but there's not. Because this number counted twice. It would be 1, 2, 3, 4, 5, 6, 7, 8. I'm not going to count that one. 9. I'm not going to count that one. 10. So it's actually 10. I'm not going to count the 1 and 3 2 times. They're not 2 different numbers. So when I do this, you can do it in your calculator. 8 fifteenths plus 4 fifteenths minus 2 fifteenths. 2/3, or you can add the numerators. Just make sure you check to see if they can simplify. This one could. So the answer to this one is 2/3. Just gonna put it up here because I don't have space. All right, you roll a fair number cube. What is the probability that it lands on an even number or a number less than 4? You guys try this one. See if you can do it. So circle the even numbers, make that a probability. Circle the numbers less than 4, make that a probability. And figure out how many numbers you circled twice. Subtract that. And that would be your overlapping probability. What's the probability of it being an even number? 3/6 or 1/2. So even, 1, 2, 3. 3/6, 1/2. All right, what about less than 4? 1/2 or 3/6. If I were to add these up right now, 1/2 plus 1/2 is 1 whole. That would mean that if I were to roll the dice, I am 100% going to get an even number or a number less than 4, which is not true. Because 5, if I roll a 5, is neither of those things, right? It's not even and it's not less than 4. So 100% doesn't make sense. That's because we're counting one of these numbers or multiple of these numbers multiple times. What number or numbers are repeated? 2. One number out of 6 numbers is a repeat. I don't want to count that number twice. So to avoid counting it twice, I'm gonna subtract it out. So I'm gonna take the probability that I get an even number, 1/2 or 3/6, plus the probability that I get a number less than 4, 3/6, minus the repeated number. There was only one of them, 1/6. So the answer is 5/6. 5 out of the 6 numbers meet both criteria. Or sorry, 5 out of the 6 numbers meet one of the 2 criteria. The only number that doesn't work for these 2 things is 5. So that's the 1/6 of the time that doesn't happen. In other words, if I were to count my numbers I circled, 1, 2, 3, 4, I'm not going to count the 2 again because I already counted it. 5. 5 total numbers. Be okay with that? Alright, the last one, you spin a spinner that is evenly divided into 8 regions. What's the probability that we land on a multiple of 4? 4 and 8. So 2 out of 8, or 1/4. Or an odd number, 1, 3, 5, and 7. 4 out of 8, or 1/2. When I go to calculate this probability, it would be the probability of the first event plus the probability of the second event. Is there anything to minus? Minus would be a number I circled in event 1 and 2. So did I circle any numbers in both events? Are any of the numbers in common here? So there's nothing to subtract. These are mutually exclusive. I don't have to do the minus because there isn't an overlap. So I'll just add them. I'll get 6/8 or 3/4. You're only subtracting if there's repeats. If there's not repeats, then there's nothing to subtract. Do you think you can try some of these? Alright, so just a quick summary before I send you off. Here's what we've got. You're gonna have a problem that says find the probability of A and B. In this case, A and B means, let's say I'm gonna roll a 5 and I wanna roll a 6 too. I want both things to happen. Okay, A and B is when both events are gonna take place. If 2 things or more things are gonna happen, we're just gonna multiply them, like we did in the warm-up. But if it says or, that means only one's gonna happen. So if only one event's gonna happen, you have 2 opportunities, mutually exclusive or overlap. Mutually exclusive is gonna be event A shares no common outcomes with event B. They've got nothing in common, there's no repeats. We're gonna add them. Overlap is something in A is also happening in B. There's a repeat here. If there is a repeat, then we're gonna add and subtract. You're subtracting the amount of repeats, right? So I'm gonna have this on the board while you do your practice, but your practice is gonna be on top of it, all right? So you're gonna choose if you think they're overlapping, if you think they're independent, if you think they're mutually exclusive, okay? We'll go over the ones that we need to. This is definitely the hardest piece of probability because all of the events kind of disguise themselves the same way, and so it's really hard to determine what's what. We will have an entire day tomorrow of practice. We're not going to do anything new. You definitely need time to see examples and think about them and determine them. But the first question I ask myself is, so for this one it says, you choose a card, replace it, and then choose another card. What's the probability that both are okay? How many cards are you picking? 2. If you're picking 2, it's gotta be independent, okay? So if more than one event happens, it's never going to be mutually exclusive or overlap. How many cards am I picking? 2, then I'm picking independent every time. That's the only one that has multiple things happening, all right? So for the next one, it says, a hat contains numbers 1 through 30. You are choosing a number at random. What's the probability you choose a multiple of 2 or multiple of 3? How many cards are you picking? How many cards are you picking? You are choosing a number at random. That's singular. You are picking 1 card. It can't be independent then, because I'm only picking 1. Okay, now that I'm only picking 1, let me think about the 2 events. multiples of 2, 2, 4, 6, 8, 10, 12, multiples of 3, 3, 6, 9, 12. Those even numbers are multiples of 2 as well. There's some repeats here. It's one event with repeats. This one's is overlap rather than mutually exclusive. All right. Number 3, if 2 dice are rolled sequentially, what's the probability that the first die is even or shows a 2 and the other die shows an even? How many times are you rolling the dice? 2. Anytime you are doing something multiple times, it's independent, okay? The fact that I'm rolling the die twice immediately makes this independent. An article contains 14 pages. You randomly open to one page. One page. So it can't be independent. Now let's look at the 2 events. Page 5, page 7. Is there anything in it that's page 5 that's also page 7? No. This one is mutually exclusive. We had that one good. All right. And then a bag contains jerseys, blah, 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 blah. If you randomly select a jersey, how many jerseys are you picking? 1. It can't be independent. I'm only picking 1. So now let me think about these 2. What's the probability that it's blue or has a number greater than 4? Are there any jerseys that are blue with numbers greater than 4? That's my question. If the answer is yes, then it's overlap. If there's no blue jerseys that are greater than 4, then it's mutually exclusive. So there are blue jerseys. So it says blue jerseys are 1 through 8. So I've got a blue 5, a blue 6, a blue 7, and a blue 8 that are blue and greater than 4, which is why this one's an overlap. It can't be independent because I'm only picking 1. And it's not mutually exclusive because there's common outcomes. Tomorrow we're going to practice actually finding them, and I think it's a little easier when you're writing them out. So I think you probably didn't write much out because it was multiple choice, right? But tomorrow I'm hoping that when you write them out, it's a little easier to see. But keep in mind, how many events are happening? If it's 2, then you got to pick A every time. If it's 1, now I have something to choose between B or C. All right, I don't have any homework for you tonight. We'll do practice tomorrow.